Hi, so in this video, I'm going to talk about Azure Databricks. So Azure Databricks is one of the most advanced big data tools for fast scaling data processing and having high throughput of data ETL processing as well as. Okay, so in this video, I'm going to talk about detailed explanation of what is Azure Databricks and how you can actually process terabytes of data.
So Azure Databricks. What is Databricks? I think the easiest to explain Databricks is it's the big data technology that Microsoft brought as one of the services in Azure. It's a very cool platform that is based on Apache Spark. Was it cool? Because it is created and designed by the same people who actually created the Apache Spark. And since Apache Spark is one of the leaders of big data technologies on the market, it really promises fast transformations in the cloud. So since it's based on Apache Spark, the key features that you would get from this are first of all, Spark SQL and data frames. This is a library that allows you to work on your structured data as pretty much tables in any system that you've been working on already. Additionally, you have some services that allow you for streaming of the data. So if you're doing IoT or live event applications, this is one of the great examples of how you can perform transformations on the live system. You also have machine learning library which allows you to do machine learning type of transformations, prepping and training models using Spark itself. You also have graphics, so if you're doing social media type of applications, then this is also a great place to do so. And everything is basing on Spark Core API, which means you can use Spark SQL, which is a little bit different than normal SQL.
It is more limited, but it's still very powerful. So if you know SQL, that could be a very good feature for you to use without needing to learn any other different language. You also have Python, Scala. Those are the two main languages that you will be using when developing in Databricks, but you also have Java if you need to do that. Databricks as a platform has a lot of features itself. Besides being Apache Spark based, it also has a runtime. Runtime combines all those features together into singular platform, which delivers you workspaces at places where you can collaborate with your friends and colleagues on your scripts. If you have multiple scripts, you can combine them into workflows. Workflows can be nesting of the scripts coming another script, basically a simple ETL. And also you have a DBO, which is Databricks input-output library, allowing you to easily connect to multiple services, both in Azure and not only like Apache Kafka and and Hadoop. But also Databricks has something called Databricks Serverless. What this really means is that when you work with Databricks, you just specify what kind of server do you want, how powerful it is, how many of those servers do you want, what is the runtime that you want on it, and that's it. Databricks as a platform will manage handling and creation of that clusters for you without you needing to manage them at all. And lastly, there's something called enterprise security. So Databricks is integrated very well with Azure and Azure Active Directory. So handling all those accesses, credentials, authorization, everything is basing on Azure ID. So you can just use your corporate credentials and identity to use Databricks itself. There are a lot of storage solutions that can connect to, but the five main ones that has native connectivity is a blob storage, data lake in both version 12, SQL data warehouse, Apache Kafka, and Hadoop. We already mentioned some of those, but also there are several applications that you can use Databricks for. The most common ones are machine learning scenarios, streaming scenarios, data warehousing, so your typical ETLs, prepping the data, and Power BI, which is very common case recently. But there are many other applications that you can use Databricks for. Since this is a collaborative platform, it is really easy for users to use it. There's a UI that they can use. I would say it's very simple. It's very simple once you know the platform. But since there is a UI, you don't really have to be technical savvy in order to use it. So your typical data scientist, engineer, analyst Once they learn the platform, it's very easy for them to use Databricks as well. The typical scenario that you would see Databricks in is during the prepper train for machine learning or your typical prep, which is part of the ETL. You normally have ingestion layers, so either Data Factory, Kafka, IoT Hub, even Hub, something gathering your data from external systems and putting it either on a blob or data lake. So this is where the Databricks come in. Usually Databricks will grab that data from the blob or data lake, transform it, or train the models if it's machine learning scenario and put it in some sort of database. It can be their SQL database, Cosmos DB, data warehouse, or maybe even analysis services. Or you, of course, can put it back on the blob storage if you want to. That's up to you since this is a scripting platform. You can actually design this logic as you fit to. So without further ado, let's go into the portal and start doing some demos. So in Azure, we will need a couple of things. First of all, we're going to need to create the Databricks. In order to create Databricks, hit on Create Resource and type Databricks and hit Create when you find the template and just give it a name. I'm going to call it a 4EDB intro. You also need to provide a resource group. This is where your Databricks workspace will be residing. So I'm going to pick my resource group that I created previously. I'm going to leave location of Europe. This is the closest data center to me. In the pricing tier, I'm going to select trial. Please note that this is the trial. The 14 days free DBU that you're getting is only the licensing cost for the Databricks that you're not going to pay for, but you're still going to pay for the virtual machines itself. So I'm going to leave the last option deployed to virtual network as no, because this is not the part of the training for today. So I'm going to hit create. And the second resource that we're going to need today, because we're going to be transforming data, and as we've seen during our presentation, we need to ingest it from somewhere. I'm going to grab a blob storage for that, where I will going to be uploading files for our processing purposes. So I'm going to hit plus and find the storage account. It's quickly here. I'm going to provide a name, but first I need to select the resource group, so the same resource group are previously. I'm going to also leave North Europe and I'm going to provide a 4EDB intro name, and everything else is going to be left as default. Of course, you can change replication if this is just the ingestion layer, so you're going to get a better performance. So if I'm going to leave locally redundant storage, this is the cheapest and the fastest storage that we can get. So let's hit review and hit create. Provisioning of resources takes about a minute or two, so I'm going to speed this up. So the provisioning finished, so we can go to our Databricks resource. So let's go to resource group, open our resource group, and those are the two resources that we just created. So I'm going to hit on the Databricks resource and I'm going to hit on launch workspace. This is going to bring me to the separate portal, the portal where you're actually going to be doing all the work. There's actually literally almost nothing that you can do related to Databricks here in the Azure portal itself, other than some virtual network connectivity. So let's go back to the Databricks platform. This initialization takes about a minute or two as well, but I've seen a rare scenarios where this sometimes takes up to an hour. So if this happens for you, just patiently wait or maybe come back later. So in the Azure Databricks portal, you can do here a couple of things, but the most important that we're going to be doing today is running the scripts and creating clusters. Clusters are the workloads that you're going to be running on the servers that will be executing your scripts. So what we need to do right now is create new cluster. You can quickly hit here new cluster and provide details of your cluster. I'm going to call it demo because the name is just important for me right now. But in case you're collaborating, always pick meaningful name. What is the cluster mode, standard or high concurrency? If multiple users are working on the same cluster, it is advised to use high concurrency. If this is a cluster for your ETO transformation, just pick standard. Next, you have pool. I'm going to leave this as none, and we have database runtime version. For the demo purposes, leave this as default, but as you see, you have a lot of Databricks runtimes. So if you need Scala or Spark in a different version, you can always find it here. So I'm going to leave runtime 5.4. I'm going to leave Python version as free. And the next two options are very important. First of all, you can enable auto-scaling. So if you're doing workloads that sometimes needs more and less power, you can enable auto-scaling, and this will pretty much bring from 2 to 8 servers for your processing needs. In our case, I'm going to disable this and change workers to run to 1. The reason for doing that is because our scripts are very, very small. And if you're going to pick more servers, not only you're going to pay more, the execution will take more time because the time it will take to split the task into 2 servers and combine the results together is larger than the actual work that needs to be done. So I would advise always for training purposes to just grab out non-auto-scaling cluster with only 1 worker. And there's very good feature here called terminate. After that means if you have a cluster and you're finished processing workloads and you went home, you stopped processing, it will automatically delete the cluster for you, so you don't pay anything at all. And this is why, even though you pay additional license for the Databricks itself, usually end up paying less than for the usual services that transform the data. So I'm going to leave this to 30 minutes. So if for 30 minutes I'm not using this, it's going to delete it, and I'm going to pick the smallest server available, and I think this is the F series. F4S is the smallest server that you can use, and hit create cluster. After doing so, your server will be up probably between 1 and 5 minutes. So again, I'm going to speed this up. So since our cluster was created and it's running, notice first of all, you have 2 nodes. 2 nodes are because there's always master and a worker. Worker is the server, a virtual machine that runs all the scripts that you create, and the master is virtual machine that orchestrates all the scripts execution and splits them across multiple workers if you have more than 1. So let's go to workspace and start creating our scripts. So hit on the workspace, go to users, hit on your username, and this is where I'm going to be doing my work right now. This is my personal workspace where I can create notebooks. So I'm going to right click, hit create notebook, and notebook is basically your scripting language. So I'm going to pick Python and I'm going to type demo1. This is going to be name of my notebook where I'm going to be writing my scripts. And of course, this is not the demo of how to write Python and Scala scripting. Therefore, I prepared all the scripts beforehand. So the first demo in Python that we're going to run is prepared by Microsoft. Microsoft gave the data that you can run very quickly to see how Databricks works. So I'm just going to copy paste that. So first of all, I'm going to create 4 variables, and we're going to create the blob account called Azure Open Data Storage to the container relative path and provide a SAS token. SAS token is your key that we're going to use to authorize to this container and pull this Boston data. In order to run this block, you simply need to hit Control Enter, or you need to hit this Run Cell button here and hit Run Cell. Our command, as you see, was very, very fast. So right now, since we executed this block is a series of commands written in Python. You can actually combine multiple blocks into a single notebook. To create a new block, you go here, insert new cell, and paste new script. Oh, sorry, that's the same script, so I'm going to copy the next one. This one is nothing to worry about. I would say this is the configuration that really needs to happen anyway. This is just for your information. This is the path to the blob storage. This is a very, not very user-friendly in terms of how to combine this, but the computation very nicely specifies how this should look like. So usually just grab this from example and replace some values. So we just need to run this. This is just for your information. This is the path to the blob storage. This is a not very user-friendly in terms of how to combine this, but the computation very nicely specifies how this should look like. So usually just grab this from example and replace some values. So we just need to run this. So that means our remote blob path is blob protocol, CT data container, Azure Open Data Storage, and safety release, CT Boston. Right? So let's grab data from this container. I'm going to grab the next script, and it says Spark read. So basically we're telling Spark to read the data. Next we're going to say Parquet. This is the format of the data. It's just like CSV or JSON file. There's also Parquet files, and do it from the path from the previous step. Then print some information and create the view. A view are used if you want to use SQL. So let's hit Control Enter and run this. In about 5 to 7 seconds, we should get data combined. It was actually a bit faster for us, under 4 seconds. So if this worked right now, we can go to the next block and maybe display something about this data. What I'm going to do is maybe I'm going to count those rows of that data. So I'm going to hit Control Enter and run the job. So we have 127,000 of rows of data that we read that we can already work on. And since we created a view called source, we can also do one of those powerful things that I was talking about, which is switching language. To switch language, you just type %SQL, and when you do that, you can start typing your SQL comments like this. So select star grabs all the row from the view called source and only grab the first 10 rows. Hit Control Enter and see the results. It's really cool that we were able to connect to external blob storage, use SQL to query the data, and display it on the screen. But what's more is that if you're the analyst and you're doing this data analysis, you can grab your data here using download CSV file and maybe pass it along to someone, or maybe hit this button and visualize it using bar chart or maybe a pie chart. Of course, as pie chart, you have additional options just like in Excel and pivot tables. You can use those here and change the values, maybe change the aggregate to count and hit apply. And this is our chart. It's pretty cool, isn't it? So that was the demo for the Python. I don't feel like this demo really shows what we did, because we not only use external storage, but we use very quick comments. We got some results. So I do really want to do more tangible, more hands-on experience with scripting. So we're going to create one more script in Scala. So let's go to Workspace, right-click, create new notebook, call it Demo2, and this one's going to be in Scala. So what we're going to do here is we're going to first upload our own data. So what I'm going to do is I'm going to upload those rows of data. There's 25 rows of data saved here as a JSON file. This is small radio JSON information. So I already downloaded this file. So what I need to do right now is go back to Azure, go to my resource group, go to the storage account that I created, and this is the reason we created it, because I want to have this place where I can put my own data, transform it, and put it back. So I'm going to go to blob service, create new container. I'm going to call it staging. I'm going to leave it as private, and I'm going to go to staging and upload my file called small radio JSON and upload it. So it uploaded successfully. Right now we have on our container small radio JSON file. That's it, what we need to do in terms of Azure. Let's go back to scripting. So this time we're writing code in Scala. So I prepared some of the code already. So first of all, for this code to work, we need the container name, storage account name, and SAS token, the same token that we were given by Microsoft. So we're going to generate that in a second. First of all, we need a container name. Our container name is called staging. So let's copy paste that and put it here. We need a storage account name. So let's go back and grab our storage account name, and we need SAS token. To get SAS token, you go to blob service, go to shared access signature blade, and select the service that need to access to. I only need access for blobs. I'm going to leave it as blob, and I'm going to leave everything else default. This means the storage that I'm giving access to has only access until tomorrow 4 a.m. in the morning. So I'm going to generate the SAS. I'm going to copy it to clipboard and I'm going to paste it here. This is very important that in this case, this is very short-lived token. So if I would run this script tomorrow, it would fail. So remember about that. I'm going to hit Control Enter, which is going to initialize those variables. I'm going to hit plus. And I'm going to add new line, and this is very important what I'm going to do right now. I'm using Databricks utilities to mount a storage. So just like you map your normal drive on your computer or Windows or Linux, we are doing the same thing here, except instead of mapping a drive, we're mapping a blob storage. This is a very, very cool feature because using just normal Windows shell, Linux shell commands, you can copy data to this mount and it will land on the blob storage. So I'm gonna hit Control Enter let's rename it differently. Let's call it staging. I'm gonna hit Control Enter. The reason it fell because I already had the demo mount before because I was testing this scenario. So let's call it staging. This command takes about 24 seconds to mount it. And from this point onwards, we will be able to use this mounting point to load our data. After almost 22 seconds, our staging is ready. So let's grab another line of code. I'm going to grab a line of code that will allow me to read from amount/staging small radio JSON. And what I'm going to do is I'm going to display this data and hit Control Enter. So as you see, it was really fast, but what is cool here is we used it like it would be normal file on our drive, except it was on a blob storage, and yet we were able to connect, load that data, and displayed. It's very, very cool, to be honest. Next, what we're going to do is going to create another block and paste it in. And here we're going to use a select statement. This is a similar to selecting SQL, where we're grabbing our data frame consisting of our data and selecting only few columns: first name, last name, gender, location, and level, and displaying that data frame to see the results. Hit Control Enter. Everything seems fine. That was the first transformation that we did using Databricks. So let's do the second one by pasting this command and grabbing the results that I saved previous step, specified specific columns data frame. And from this result, I'm grabbing and renaming one of the columns called level to subscription type. Let's hit Control Enter. And again, see the results? The column was renamed. What else you can do here is the same as previously. Maybe let's create a view called renamed, Control Enter, and the view was created. So how about we do some simple aggregations, maybe count how many subscription types are there. So I'm going to type %SQL and select count by subscription type. Hit Control Enter, and we got 10 free subscription and 15 paid ones. And if you want to save this as a result in some data frame later on, you just encapsulate this select statement into Spark SQL and assign it to aggregate variable. Hit Control Enter, and now in aggregate variable we have a dot aggregation that we created a second ago. So since we have that, we can already go further and maybe save that on the blob storage. So let's grab one more line and grab aggregate, so the result from the previous step. Write mode override, so if there are any results on the blob storage existing already, override them. Write it as a JSON file. So this is the specification of the format. It's pretty much as easy as changing this to CSV, and we're going to have a CSV file. So let's hit Control Enter, and it finished. So if it did finish and we didn't mess anything up, we go back to our blob storage. We go to the Overview tab, go to the blob service, staging, open output, aggregate CSV. We have a file that is empty 0 bytes because this is just a metadata file. And within the aggregate, we have some information here, but this is a splitted CSV file. Actually, sorry, this one, see, this is a CSV file, 10 free ones and 15 paid ones. Why is it split? Because this is how Spark works. It's print splitting data into partitions for more effective processing. Of course, you can control that. If you want to have singular file, you can always combine this data using simple commands. But I just wanted to leave this as brief ones. What is cool is that Databricks and Spark itself knows how to use those files and how to combine them in a singular data frame. The other files that you have here is success, which is the status of the processing. You have the started file, which says when the processing started. You have committed file. This is the file that says how many files did you create during this processing. It says we created 2. So it's pointing to this and this file. So this is how Spark knows which files to pick during, and that was processed and how to process this further. So if we go back to our presentation and talk about very last thing that we just to summarize the information that we learned here. First of all, you have Azure. In Azure, in the resource group, you have Databricks Workspace. This is the resource that combines features about the service, but only very limited features, because in reality, you have the separate fee service in the portal called azuredatabricks.net, and there's a region and workspace ID, so it's separate portal, and you do pretty much everything in that portal with regards to Databricks. What you can do there is, first of all, you can have workspaces, shared ones or per user's workspaces. You can manage clusters, you can manage jobs. Jobs clusters are basically a cluster that you create to run a job and immediately delete it after the job. You can have machine learning experiments and many, many more. One interesting fact is that whenever you create a cluster, there's another resource group created in Azure that is hidden from you if you're not an administrator where your cluster resides. machines. So as you know, we had a 2-node cluster. That means there's a resource group in Azure right now which has 2 virtual machines in that resource group, which is basically our cluster. And this is what you're going to pay for those virtual machines.
We are done. So in this video, we have seen how to connect blob storage to Databricks and how to ingest the data from there and sending as a data warehouse inside the blob storage. Databricks is one of the most power tool as you have seen that to process petabytes of data. This pipeline is useful for making it happen. So if you understood something about Databricks and if you like it, please subscribe and comment down for next video that you are looking for. And if you want to really learn data engineering in detail, you can join our channel. That is the links are available inside the description. You can take it from there. Thanks a lot.